Alright, everyone. We are still in section 5.3, and in section 5.3, what we did earlier were the problems that were pretty straightforward. They were almost like your one-step equations in algebra. Now let's ratchet it up a little bit to problems where you might have to use a little factoring. You might have to use some identities. You might have to use lots of different methods to be able to solve. So, um, let's look at 2 sine squared x plus sine x equals 0. And we want to solve this for all solutions. Okay, so now notice what we have. We have a sine x in common. So like you do in algebra, I can factor out a greatest common factor here. And using the zero product property from algebra, I can set each one of these factors equal to 0. Now, of course, on this first factor, we already have sine x equals 0. On the second one, we would need to solve. And so that gives me a -1, and then divide by 2. So sine x equals -1/2. Okay, sine x equals -1/2. Now, these are your two equations that you need to look at to try to solve. Okay, so think in terms of your unit circle. Okay, think in terms of our unit circle. What two solutions, or what I should say solutions, not two solutions. It happens to be two for this problem. But what solutions have a sine, or what angles have a sine of 0? Well, the angles that have a sine or a y value of 0 are at 0, pi, 2 pi, 3 pi, so on. Okay? So, there are two angles on the unit circle that have that solution, and that's 0 and pi. Now, 2 pi is all the way back around the circle. So we know that 0 and pi are two solutions, and excuse me, and if we go all the way back around the unit circle, we get to 2 pi. If we go from pi all the way back around the unit circle, we get to to 3 pi. So because this is a sine function, we need to add 2k pi to each one of these, because this will give us all the infinite many solutions of the unit circle. Now, why do we not include 2 pi? Because 0 plus 2 pi gives us 2 pi. So that would be one of the answers of 0 plus 2k pi. Okay? So that's the answers to sine x equals 0. Now, where on the unit circle does sine x equal -1/2? Well, right here at 7 pi over 6. And if you look straight across the unit circle to the same point over here, sine x equals -1/2 at 11 pi over 6. Alright, so we can write down those two. Those are the only two spots where sine x equals -1/2, and add 2k pi, and that will give you the infinite many solutions that equal 1/2. That will give you the infinitely many solutions that equal 1/2. Okay? So it's all about finding those solutions that give you those answers on the unit circle. And then, since this is sine, we add 2k pi to it. If it was cosine, we would add 2k pi to it. Remember, sine and cosine, we're adding 2k pi to get all the infinite many solutions. And with tangent, we add k pi to get the infinitely many solutions. Alright, so let's look at the next one. Alright, so let's solve this one. Now notice what happens here. I'm going to put a restriction on this. We only want the answers to be between 0 and 2 pi. And notice 2 pi is not included in that interval. So I just want my answers will just fall on the unit circle. That's basically what that's saying. You're not going to have to add 2k pi to this particular problem because we're not trying to find all the infinitely many solutions. So here's where you have to, this is an example of where you have to use an identity. Because sine of 2x is the same thing as 2 sine x cosine x. And if we subtract sine x from both sides, this is what we have. Now, why is this important? Because now I can factor a sine x out of the problem. Alright, so sine x equals 0, or 2 cosine x minus 1 equals 0, or cosine x equals 1/2 if you were to solve that. So these are the two equations that we're trying to find answers for. Now remember, because of our interval, we don't have to worry about the 2k pi, so we're only trying to find answers that fall on the unit circle here. So where does sine x equal 0? Well, since 0 is included, sine x equals 0 at 0, and sine x equals 0 at pi. We can't use 2 pi because it's no equal to bar. So we know 0 and pi solve the first equation. Well, what about the second equation? Where does cosine x equal 1/2? Well, cosine x equals 1/2 right here at pi over 3. And because it's cosine, remember we can draw our line and we can find the other cosine right here, which would be 5 pi over 3, is where has a cosine of 1/2 as well. So because we're just looking for unit circle answers, these 4 answers would be the answers to our problem. Where does cosine x equal 1/2 on the unit circle? Pi over 3, 5 pi over 3. Now, what if we didn't have these? What if we didn't have this interval here? Well, we would be able to add 2k pi to each one of these to get the infinitely many solutions. Okay? Hopefully that makes sense to you. Now, of course, I can only give you so many of these problems, folks. There's an infinitely many examples. Okay? So it's going to be very important for you to do these on homework, and I would even turn to this section in the book and maybe work the odd ones that have equations so that you can, those answers are in the back of your book, you can check yourself. That way you'll be able to get more practice with these. You're going to need as much practice as you can possibly get. Okay? Alright, so find all the solutions. Our next problem, our next example. Let's find all the solutions in degrees for this problem. Now remember, I want to find it in degrees. Theta divided by 2 equals cosine of theta minus 1. Alright, so first things first. I want to make this problem easier for me to solve. So I'm going to let alpha equal theta over 2. So theta equals 2 alpha, essentially. 2 alpha. Now, why did I do that? This is very similar to the U substitution problems that you solved in college algebra. Okay, so if you still have your college algebra book, section 1-6, okay, these are very similar to those U substitution problems. So I can, because of this, I can rewrite this problem as sine alpha equals cosine of 2 alpha minus 1. Alright, well, now I've changed the cosine. I've gotten rid of the half angle identity, but I ended up with a double angle identity with the cosine, and that's fine. And here's why. I'm actually going to use one of our double angle identities to solve this particular problem, and the one that I'm going to use is cosine squared minus sine squared. So I'm going to rewrite this as cosine squared alpha minus sine squared alpha minus 1. Now, you're asking yourself, I know right now, Mr. Francis, why did you do that? Why there were 3 formulas for cosine of 2 alpha. Why did you choose that one? Well, here's why. Because of this right here. We have a Pythagorean identity that says this. So because of that, what we're able to do is we're able to get everything in terms of sine alpha now. Because if I solve this for sine squared, if I solve this for cosine squared, I get 1 minus sine squared alpha. Okay, these should be alphas. If I do that and solve that, I can make this direct substitution into this problem here. And now look what I have. I have 1 minus sine squared alpha minus sine squared alpha minus 1. So what this essentially did is it got everything in terms of, I was able to use one identity here. I was able to use an identity here to get in terms of cosine squared and sine squared. And then I was able to use our Pythagorean identity to change that cosine squared to a sine squared so that I got everything in terms of sine squared. It just makes it easier to solve the problem. Okay, so we have sine alpha equals, the 1 and negative 1 cancel each other out, so we have a negative 2 sine squared alpha. Alright, so what I can do is I can add 2 to both sides. I add the 2 sine squared alpha to both sides, and I get 2 sine squared alpha plus sine alpha equals 0. Now, why is that so important? Because now I can factor. Look. Sine alpha times 2 sine alpha plus 1 equals 0. So I have sine alpha equals 0. Or if I solve this one, I'll have sine alpha equals negative 1/2. Sine alpha equals negative 1/2. Okay, so Think of your unit circle. And that's a poorly drawn circle, but think of your unit circle, okay? Let me fix my circle. There we go. So think of your unit circle. Where does sine alpha equal 0? And so we know that that's at 0 in pi. Now here's the little catch to this problem. 0, pi, and I'll show you the catch here in a minute. So where does sine alpha equal -1/2? So what angle has for its sine values -1/2? Well, they're both down here. And so what you end up with here is what? What angles are these? These are going to be 4 pi over 3. Pi over 3. Excuse me, not 4 pi over 3. I'm looking at the wrong problem. What is that going to be again? We're 30 degrees from 180. So that is going to be 7 pi over 6. Sorry about that. Alright, and what would this other one be? Well, this other one would be 30 degrees from 2 pi. So that's going to be 11 pi over 6. Now, here's the deal with this. In this problem, in the beginning, I told you we wanted it in degree form. We wanted it in degree form. So obviously, 0 is still 0 degrees. But pi is going to be 180 degrees. 7 pi over 6, if you change that to degrees, is 210 degrees. And 11 pi over 6 is 330 degrees. Now here's the part people tend to miss, or one of the parts people tend to miss with this problem, is that instead of adding 2k pi, this is a sine problem, and we're finding all the solutions, so we would normally add 2k pi, or 2 pi k, however you want to look at it, to every one of these. But we're not in radian form, we're in degree form. So what would 2k pi look like in degree form? Well, 2 pi is the same thing as 360 degrees. So it would be 360k. Okay? So add 360k to every one of these. And this thing is writing very slowly, so excuse me for that. 360k, 360k, and 360k. Now, because this is writing so slowly, I'm going to tell you how to do the rest of this. Okay, so we're not done. You're thinking, well, you got the answer right there, Mr. Francis. Well, you got the answer for alpha. We didn't start out with alpha, did we? We started out with thetas in this problem. So what does theta equal? Theta equals 2 alpha. So in order to get the final answer for this problem, you would have to multiply each of these by 2. So, what is that going to look like? Well, that is going to look like this. This is the answer you have right now. You have 0 plus 360k. You have 180 plus 360k. You have 210 plus 360k. And you have 330 plus 360k. So these are all alpha answers. Well, theta is what we're solving for, and theta equals 2 times alpha. So you have to multiply all your answers by 2. So this is going to be 0 plus 720k. Notice I even multiplied this by 2. You have to multiply it all. So this is going to be 360 plus 720k. This is going to be 420 plus 720k. And this is going to be 660 plus 720k. Now we have our final answer. We have theta. Okay, so this is what our answer would look like, where k is any integer. Now that's one of the more difficult problems you could have. So rewind this, watch it over again so that you can get the hang of it, okay? I want you to be able to do one like that. Alright, and last but not least, this will be the last one we do here on here, because there's only, like I said, there's only so many I can give you. 8 sine squared x equals 5 plus 10 cosine x. We want to find all the real solutions. Alright, so let's get all this on one side. Minus 10 cosine x minus 5. I'm kind of putting it in a standard form like area here. So I can't change the cosine x, but I can change sine x to get it in sine squared x to get it in terms of cosine x. I can change sine squared to 1 minus cosine squared using our Pythagorean identity here. Okay, so this just gets everything in terms of cosine. Makes it a little easier for us to solve. So we have 8 minus 8 cosine squared x minus 10 cosine x minus 5, which should give us a very nice negative 8 cosine squared x minus 10 cosine x plus 3. Now, this makes for a hard problem right here if you leave it like this. But what I'm going to do is I'm going to multiply everything here by negative 1. It just makes it, the reason why I'm doing this, folks, is we're about to factor, believe it or not, just like you did in algebra. We're about to factor, and as you well know, it's easier to factor with positives than it is with negatives. So if you multiply by negative 1, this is what we have. Alright, I'm going to go to the next page so it's a little easier to write. Alright, so this is what we have. We have 8 cosine squared x plus 10 cosine x minus 3 equals 0. Now, if you were to try to factor this, just like we would in algebra, you would get 2 cosine x plus 3 and 4 cosine x minus 1. Alright, so we have this set ready to go. So we have factored it. So set each of these equal to 0 and solve. And if you do that, you get cosine x equals negative 3 over 2 for this one, or cosine x equals 1/4 for this one. So now this is very interesting here because what we have here is we have two problems that we're going to have to actually we have two problems that we're going to actually have to do the inverse on. So we want to solve each equation. We want to find the unit circle version of each equation. So now cosine x is 1/4. There's going to be it's going to be either in quadrant 1 or quadrant 4. Because remember, this point is 1, this point is -1, 1, -1. So 1/4 would be somewhere in here. Okay? Because the cosine represents the x values. That's how I know that. So cosine would be somewhere in here. So let's take the inverse cosine of 1/4. And that's going to give us our x. Now let's round that, it says in the problem, to 4 decimal places. And so when you do the inverse cosine of 1/4, you get 1.3181. So that would be the one up here. Okay? That would be this one right in here. It'd be 1.3181. Now, there's also an answer down here, remember. Well, how would we get to that answer? Well, this goes back to what we learned earlier. Remember, this distance here should be the same as this distance here. So since the distance all the way around the circle is 2 pi, we can subtract from 2 pi 1.318, and it will give us what this value is right here. The value we're looking for, which happens to be 4.9651 to 4 decimal places. 4.9651. Couldn't get it all written over there. Alright, so there's two values for on our unit circle for where cosine x equals 1/4. Now, why do we have to do the inverse? We actually had to type this in your calculator. Why? It's because we don't have an exact number or exact angle that gives us 1/4 on the unit circle. You have to actually punch that out in your calculator. That's not one of your unit circle values that you memorized. So if it's not one that you memorized, you're going to have to punch it in the calculator like we did here. All right, now let's look at the other one. Where does cosine x equal negative 3 over 2? Well, there's a little bit of a problem here. Because what does negative 3 over 2 equal? It equals negative 1.5. Negative 1, negative 1, 1, 1. Negative 1.5 is not on this unit circle. Not on the unit circle, because we only go to from negative 1 to 1. So this particular problem here, this part of the problem, has no solution. So you're only worried about the cosine of the inverse cosine of 1/4. This would be this answer, as well as 4.9651 would be the only ones that you would worry about for this particular problem. Now, those are just the two answers on the unit circle. How would we find all the solutions? Well, this is a cosine problem. So what are we going to add to this? 2k pi plus 2k pi. And this would give us all our solutions. Okay? So I wanted you to see a problem where we actually did a I wanted to show you a problem where we actually did a some without that were decimal numbers where they didn't have word in degree or radian, so to speak. It was our pi radians. It was in a decimal form. I wanted you to see that so you would see how to handle it. Okay, so now remember, any algebra computation is going to be on the table. Um, what I would do when I'm getting ready to solve these problems is I would go through these kind of steps. I would say, okay, I would try to solve it for a trig function first. See if it's one of the easy ones that you can solve just like that. If not, then you need to try using your identities. Okay? If you use an identity and you still can't solve it, then that's when I would start doing some algebra. Factoring, combining fractions, quadratic formula, all these anything that you can think of that's an algebraic manipulation could be used. Okay, it's on the table. And then find all your solutions by either adding 2k pi or k pi, whether it's sine or cosine or tangent, that depends. Okay, so keep that in mind. These are the ones you're going to want to spend the majority of your time on. Okay, so for this week's quiz, so make sure you can solve all these equations. If you have questions, please ask.